chassis will use a CNC tube notching plasma cutter machine that I'll build. I've got software that I'm going to use to model the structure of the chassis, refine it after this prototype is done, make some changes based on living with it, and space, safety, weight, cost, ease of manufacturing, and then a few other different things, and build a machine that will basically cut out each of the pieces from the chassis so that I can assemble them. They'll all fit together. Each chassis will be exactly the same, and then it will also be a lot more cost effective. So if I was to make chassis by hand, the way this one was, taking each piece, cutting it with a machine, fitting it in a jig, measuring, aligning, checking, and cutting everything, probably take about a year to actually build a chassis. So the space to do the work in, and then the cost for somebody to do that, say if I was to hire somebody, would probably be about $90,000 roughly. It's a rough guess. $90,000 to build a chassis, which is completely ridiculous. So with a plasma cutter that I can model, I'll probably have to do lots of test pieces, but once it's up and running, it will probably take about a month of work to build a chassis, I'm guessing. With a jig, so once the machine cuts all of the pieces, I can put them in the jig, the pieces fit together because they'll have notches and grooves, so they'll fit, and then I can assemble it. Probably a month worth of work. Total cost to build one of these chassis with the space, labor, and materials probably going to be around $13,000 Canadian, which is 9 or 10,000 US, which should be in the ballpark of reasonable. Each of them can be slightly customizable. There will be some modifications. I think certainly removing some material in certain areas for weight or adding more for certain types of vehicles is a definite possibility. The plan is to make the product as good as I can over the next couple of years. I'll be selling them below cost to anybody who's interested, and then after that point, then I should be able to be competitive, and the price will be something that will make the business sustainable. Yeah, so I'll show you the demo. I'm going to do a quick demo of the software that I'll be using to fabricate the chassis with the CNC plasma cutter. So I'm using custom CAD software, and I've added tools that will let me design and model the structure of the chassis with a way that will let me cut them out with a plasma cutter. So I've got some example. This is just an example with a tube, and it has some notches in it. So this section of tube can interact with, say, another piece right there. And this line right here, represents the interaction of the tubes, so that this tube can be cut along this line here, and it will match with a corresponding perpendicular piece. This notch also has like teeth, so you can see it's facing the other direction. On the top and bottom, there are these teeth that will stick out, and those can correspond with holes in the corresponding piece, so that there's no question about where the two pieces are supposed to align. The notch will fit the contour of the tube, and then the teeth and holes will make sure that all of the pieces are in the correct spot, and that every chassis will be roughly the same. So I can take this sample tube, and I've got a tool that will let me perforate. So one of them is triangles, and you can see that it fills this object with splines that represent holes that will be cut out of this material. So you can see the triangles have been placed around the tube, and I want to get rid of some on the edges, because I want strength where the material is welded, and then on the other side too. So I've got a tube, I've got 2 notches, and it's totally perforated. This is about 50%, so half of the weight of the material will be cut away. So I select the mesh. The object with inside of it contains all of the splines that represent what I want to be cut, and I can take it to CAM, which is computer-aided manufacturing, and then export it to G-code for the notcher machine. The notcher machine basically takes that computer controller. One axis will be the length of the tube, and then another axis will be rotating the material, and then another stepper motor will have to actuate the actual plasma cutter. So as the head is running along this material and the material is rotating, it can actuate the plasma cutter to cut out all of these patterns. So this tube, I've added squares. I won't use squares, I don't think. I don't know. I'll cut a few pieces and then I'll bend them and just see how they compare. This was just really easy to make, so I added it. The third one, which is actually pretty interesting, are diamonds. So each of these represent a material that's going to be cut. So you have to visualize that this material right in the center is what will be left of the structure. So these can be exported to G-code and printed. Now, when it comes to bent tube, so several sections of the chassis are bent. They're curved tube, and being able to cut the material and in such a way that when it's bent, that it fits in the chassis is, this is the workflow. So with a bent tube, I create in the CAD application a curved spline, which is a line that's connected by points, and have it represent the curvature of bent tube. So in this case, I've added 2 points that run through the center of this bent tube. And within the curve, then I add a mesh object, which represents the actual structure of the bent tube. So if I look at this was done really quickly, so it's not round, but ideally it would be a round tube. So this tube is within the spline mesh, and then within the mesh, I add all of the curved splines that represent what I want to be cut from the material. So I've got these 2 notches on either end that will fit with a corresponding piece, and I just added these random shapes just as a sample, just as an example. So in order to work with the curved tube, I select the spline, the curved spline, and then I go straighten. So this is a destructive function, so if you use this, you'll want to copy paste. This is just a workflow for now. So it basically takes the curvature of the spline, and for each segment it unravels it so that it's all straight, and it twists each of the pieces along the structure of the mesh, so the notches and any holes or any other kind of shapes that I want to put on the tube, it unravels it so that it's straight. The more points that you have on the spline, the straighter the unraveling will be. So just, you can see I had about 10 points in this spline, and you can see it's a little bit curved, but this is just for demonstration. Now that I have a straight mesh tube with the notches and structures that I want, I can add notching. So I'm going to add diamonds. That's a lot of diamonds. Now I'm going to remove some of the notches on the edge. Maybe a little more. And then the other side. So I've removed some of the perforations from the edges, and I can also do that to the areas where I've got my squares. And now I've got a mesh, and I've got it filled with all of these perforations that I want to cut with all of the other features. So I can select the mesh, and then CAM, computer aided manufacturing, and then export it to the tube notcher. So this will basically take the geometry that represents all of this information on the tube and export it to the G-code that the router will cut for the material from. So there's going to be a cutter that runs along the length and then also rotates the tube and then actuates a plasma cutter that will cut out each of the features. Each of these shapes will be cut out of the tube. So now that I've exported the shape for this object, I can take a look at it in a preview. Load that up. And what it's done is, this is a representation of the G-code. So you can see this section here is basically the tube as it's been unraveled. So this is how normally these CNC routers are a bed. So they've got an X and a Y axis and then a height. But the tube notcher, we basically take the Y axis and we roll it around the surface of the tube. So it's going to cut out the notch and then go through each of these perforations. So here's some of the stuff that I'm going to use to make the plasma cutter. So this was made by buildyourcnc.com. So it's got the computer and software all set up, the drivers, and everything is ready. And I've got chain and stepper motors. So soon I'm going to get some metal and start building the table and then start putting that together. I literally just finished the demo and it just shut off. Was the battery dead? Yep, there it goes. That's what happens when you leave your MacBook plugged in for all its life. I don't even remember when I bought this, a couple years ago. So the battery only lasts, I don't know, 30 minutes now. Super.